Good evening, everyone. Welcome to today's session. IEEE Kolkata section and Women in Engineering Kolkata section presents its fourth episode of Dare to Dream, a talk series on Indian women who have ventured into STEM careers more than 50 years ago. I am Sudeshna, the chair of Women in Engineering IEEE Kolkata section. Thanks to our section chair, Dr. Shushmita Mitro, all members of IEEE and we, and all our guests for joining in today's session. We started this session earlier this year, and as we step into the 75th year of Indian independence, we are hosting yet another episode on an outstanding woman born in the pre-independence era. Dr. Purnima Sinha was an Indian physicist who was the first woman to be awarded with a doctorate in physics by the University of Calcutta. We are privileged to have Dr. Sukanya Sinha, physicist and daughter, to speak on the life and works of Dr. Purnima Sinha. Before I introduce her and hand over today's session to her, let us quickly have a recap on our series. I will quickly share my desktop for a couple of minutes. Um, is it visible?
Yes.
Yeah. So just a quick recap. As I mentioned, we started this series earlier this year, and our first episode on 6th of February was on Professor Rajeshwari Chatterjee, and Dr. P.K. Basu was our honorable speaker on that day. And that was the first one we started. The second episode was on Dr. Bibha Chaudhary, and we had Dr. Shuprakash C. Roy, who presented on the day. And our third episode was on Miss Ila Majumdar, and Professor Indranath Sinha was the speaker for the day. So those of you who are interested, please do visit our Kolkata section YouTube channel, and you will even get the recordings for the previous episodes. And that is our intent. We will be storing all these recordings, these stories from an archival perspective also. And we plan to take forward this series even, we try to do one episode every alternate month, and we have another at least 5-6 plan ahead, and we want to continue this series as long as possible. Now coming back to today's session, let me quickly introduce Dr. Sinha. Dr. Sukanya Sinha received her PhD in theoretical physics from the University of Maryland. Her field of research lies in the interface of general relativity and quantum field theory. She's also very passionate about communicating science to the general public and writes in English and Bengali for both adults and children. She received the Rabindra Smriti Puruskar in 2010 for science writing in Bengali. She was a founder director of Curiosity Science Education, an organization for promoting interest in science among children. At present, she teaches physics in Indian Statistical Institute, Bangalore. Ma'am, welcome to this session, and over to you. I will just
Okay.
unshare my screen.
You will share.
Yes, I will stop sharing. I'll make you the presenter.
Okay, so I see the share button highlighted and looks like
Yeah.
it is, I'm sort of technology challenged and this is a different platform, so there might be some glitches. So bear with me. So let me start sharing. Let's see if it works. Okay, here we go. Yeah, I hope people can see it. So the
Yes.
mandatory, can you hear me? Can you see me kind of thing in these platforms? And first, I would like to thank, it's really an honor to be invited to give a talk in this series. And I thank IEEE Kolkata section and the Women in Engineering Kolkata section profusely for giving me this opportunity of um, giving a talk on the life and work of Dr. Purnima Sinha. And it's very doubly special for me because she's also my mother. So it's really a great honor. So I'm going to start, and this is basically in the perspective of, as the previous ones have also been, um, not only describing her work, a little bit of historical perspective. She was born in pre-independence, worked in, started research just on the brink of independence, and then worked in post-independence in India. And what into taking up a field which was very male dominated. And I mean, what are the factors and what was going on in the rest of India and the world at that time? I'll try to give like little insight into it. Okay, so I'm going to do a slideshow, but I'm going to go back and forth between a slideshow and this format because I want to keep referring back to a timeline and coming back to it. The second reason is that as soon as you start doing slideshow, you lose all the rest of the people, and it's kind of a bit disconcerting to be always talking to yourself. So let me start. So let me, let's see if it works. Yeah. Okay. So I'll start by putting up, so Shuprakash is also on this panel, I was pleased to see, and I'll put up a picture by Roy and Rajinder Singh on Purnima Sinha and the cover of it. And it is, it's been published a couple of years very recently. And I put up the cover because it's a rather unusual title for a woman working in STEM, primarily a scientist. Okay, let's see. Yeah, hit something accidentally. So where it says clay, craft, music, and science, Purnima Sinha's life. And it is rather unusual, and she had a rather unusual and unique life where, and this I realize not necessarily in this order, but probably this is in alphabetical order, but and science sort of comes last, but that's not necessarily true. But it's true that all these aspects were woven into a thread, into a life, and it sort of moved back and forth. All of these aspects played a great role in her life. Not only science, but art and music as well. And it starts with, befittingly, it starts with clay. And clay is a recurrent theme in her life, not only in science, but even in art. And we'll talk about it a little bit as to what that exactly means and how it happened. So first, let me put a timeline, and what I'm going to do is examine, parts of the timeline, starting one by one, starting from early childhood and the influences, because those are very crucial as to what makes the person that she was and her work. So let me. So this is sort of the rough timeline. That she was born in 1927 in Calcutta. So this is pre-independence. And she started her BSc in 1947. She got her BSc degree in 1947, dot on independence. And then went on to get and then started her MSc, sort of just as the first batch post-independence in 1950 from Calcutta, both from Calcutta University. This was from Scottish Church College. And then between 1951 and 1955, she was engaged in research in Science College under Professor S.N. Bose. And so let's hold on to this part of the timeline, and then we'll go on to the rest. I'll come back to the timeline when I need to. Okay, so let's start with the background, the childhood background, which family she was born into, because this was 1927. It was not common to study, go into get proper schooling, let alone go into higher education, and that to science. So it would be instructive to see what went on, what kind of background she came from. And so here is, I'm talking about the early childhood and family and influences. And she was born into a very rather special family. And she was the 8th and youngest child, born to Naresh Chandra and Lavanya Prabha Sengupta. And Naresh Chandra was a very special person in many senses of the word. He was a reputed constitutional lawyer. He was a scholar of jurisprudence and a very well-known progressive author who had written over 60 novels and many, many essays. Some of them also talking about women's education, workers' rights, peasants' rights, cooperative farming, many things like that. Also, he held rather extremely progressive views, and he was involved in a controversy with an essay that he wrote called Sahitya Dharma Shimana, which dealt with what is the definition of obscenity in literature. I mean, and a lot of his literature dealt with, his novels dealt with subjects that were rather, that were held as social taboos. So he was definitely a person who was quite well ahead of his years. So he had liberal political views and was best party between 1925 and 26, and the Labour Party in 1934. And he was deeply committed to the cause of women's education, and that was reflected in how he raised his daughters. Because he put a lot of, and so there was the atmosphere at home was that of tremendous freedom. There were very few restrictions. They were allowed to read anything they want, speak to, associated with people of their choice. So it was quite a departure from, so this is what she was raised under. And also the fact that this was, at that point of time, a lot of, for example, you had heard about the talk on Bibha Chaudhary, and she came from a Brahmo family. So it was, so a lot of Brahmo families were very progressive, and women had extra rights and so on and so forth. But it was not so common in Hindu families. So this was quite an exception. Now, Purnima Sinha, she had, did she do work or back home and started from scratch? No, because she had rather impressive role models, because her eldest sister, not eldest, but I think the second, because the eldest sister passed away before she was born, and Shushuma was born in 1903, and she was She was 24 years older, 24 years senior to her. And she was the first woman to receive a master's degree in economics from Calcutta University. And another sister, Purnima, who was born in 1913, 14 years her senior. And she was the first woman to receive a master's degree with thesis in chemistry from Calcutta University. And she was exactly sort of Bipa Chaudhury's contemporary, born in 1930. So she had, this was a rather special atmosphere, a privileged atmosphere that she was born into. So let me share a picture of my grandfather, Dr. Naresh Chandra Sengupta, because he was undoubtedly the greatest influence in her life and made her what she was. And I would say that even though he died when I was only 6 years old, a lot of his influence permeated into mine and my sisters and my cousins' lives, so that it also made us what we are now. He was certainly somebody who showed the path. Okay, so let me, yeah. Now, the thing is that so she was born in 1927, and and her schooling was, so whom I talked about, Shushma Sengupta, was not only, I mean, she was an economist, but she also was very interested in, she was an educationist, and she started a school for girls called Lake School for Girls, which is still in existence. And in in those times, it was a really uphill task, because she had to go from house to house to ensure parents, beg parents to send their daughters to school. A lot of them said, like, we cannot send them to a school where they have to actually cross the tram line and go so far, and so on and so forth. So it was like a quite Purnima started school on the day in class 1, the day the school was started, like School for Girls. So that's where she did her schooling. And so then post-schooling, this goes to, let's go back to the timeline. So this is, then she chose, so it was not, she was inclined to natural sciences, and she chose to chose physics as her choice subject. And she went to Scottish Church College to study physics, BSc in physics. Before that, she did her IA in Ashutosh College. But another point to note that Scottish Church College was a co-ed college, and many parents would not send their daughters to a co-ed college at that point. Naresh Chandra Sengupta had no qualms about that. Presidency College did not accept women at that time. So Scottish Church was one of the few colleges that had accepted women, not being a women's college, but so that's where she did her BSc, and then joined MSc in, so I will, yeah. So she started MSc as one of the first post-independence batches. Okay? And she was, not surprisingly, the only woman in a class of 60 men, of course. So this was a very interesting time. This was just post-independence. There was a lot of fervor of nationalism, building a new nation, and excitement to look forward to. And this was also a golden era of physics in Calcutta University. And she was taught by stalwarts like Meghat Shah, Inar Sen, Shishir Mitra. So it was a great time to be working in Calcutta University, studying in Calcutta University at that time. Now in MSc in those times, and I think even now, you had to choose a special paper, in the sense that what you were, a specialization, and she chose to study X-ray crystallography, taught by S.N. Bose. And she was very impressed. You know, he was a great teacher, had a great rapport with his students, and the science was fascinating. So she had a natural gravitated towards his subject very naturally, having taken this up as the special paper. Now, a little bit of background about X-ray crystallography. To some have heard of only as the creator of Bose-Einstein statistics, a famous theoretical physicist who essentially not collaborated with Einstein, but independently was on par with Einstein and discussed with him and developed a very fundamental, I mean, one of the fundamental pillars on which theoretical physics rests today. But it may be unknown to many that he was also very interested in building an experimental base in India, because X-ray crystallography was a new field, a very thriving field at that time, and he wanted and he was interested. He could have gone on with his theoretical physics completely and not paid attention to this stuff. But he was not only a great physicist, an outstanding theoretical physicist, but he was also interested in nation building. So he felt that if India has to have a good physics program, there has to be emphasis on experiment. And when he was in Dhaka, I think between 1924 to 26, he traveled to Europe. Apart from meeting Einstein and other theoretical physicists, he also worked in the lab of Maurice de Broglie, who was a brother of Louis de Broglie, and learned these techniques of X-ray crystallography and built a lab in Dhaka, later on in Calcutta. So Purnima Sinha, after her MSc, she later joined Professor Yasin Bose as a PhD research scholar, working on X-ray analysis of clay minerals of India, which was also interesting because this is something intrinsic to India, and understanding the clay minerals using this technique. And another very interesting thing was that this was research funded by an industry. So her research was funded by Assam Oil Company, which had an interest in clay because knowing the structure of clay was important to know like what kind of drilling you have to do, or I mean, it was in their interest. And actually she, because it was industry funded, the scholarship was very high, you know, like in those days, I forget the exact amount, but it was much higher than in amount than the university funded scholarships. And she, when my father and she were both working on their PhDs, her scholarship was much greater than his. Yeah. Okay. Another interesting feature on when she was doing her PhD, and this I think is very important, is that in a moment that she and this I think also should be understood in the context of you know, the zeal of building India, rebuilding India, independent India, that Shutan Bose encouraged students in his lab to be fabricating their own instruments, not ordering ready-made stuff from outside. And in any case, it took a long time from the way to get instruments which were, you know, and expensive too, which were commercially available. So they fabricated their own instrument, and she fabricated her own instruments using an X-ray tube, including the X-ray tube from scratch, and often using scrap material from World War II surplus. So that I think like was very remarkable. and she published her research results in a very reputed journal, Nature. Okay, so let me just talk about. I mean, many of you know this stuff in detail, but a very brief history of X-ray crystallography. It was developed by Max von Laue and the Brags in 1912, and it proved to be a very powerful tool to probe the molecular structure of matter, and it continues to be. Because, of course, we cannot see if we look at a piece of a lump of matter, we cannot see the molecules and how the molecules are arranged inside. But X-rays can actually see molecules. And by through probing through X-rays, we can actually indirectly infer how molecules are arranged in matter. So the thing is that X-rays are very high frequency electromagnetic waves. So their wavelengths are comparable to atomic spacings of lattice spacings in crystals. So crystals actually act as natural gratings and create diffraction patterns. So the technique is basically that you have an X-ray tube and you send out X-rays and you have your whatever your target, and the X-rays pass through it and create a diffraction pattern. And now from the diffraction pattern, which is actually not, it's on a photographic plate, two-dimensional, and so you have to reconstruct the three-dimensional model of the molecular structure of whatever you're trying to look at. So that's the basic idea. Okay, so now just to share certain historical timelines as to like where people were in India doing this and that it's important. So Watson and Crick, one of the most important discoveries in the history of science is the structure of double helix structure of DNA. And Watson and Crick discovered the double helix structure of Rosalind Franklin's using Rosalind Franklin's X-ray diffraction photograph in 1953. And this was during the period Purnima Sinha was also working on her thesis project of X-ray analysis of clays in Calcutta. So it's like not, so this technique was being, okay. Now, since this is about women in physics, thought I would share an interesting curious historical snippet. Of course, the father, William and Lawrence Bragg, father-son pair, they set up this, they were pioneers in setting up this X-ray crystallography lab. And it turns out surprising to know that they were very progressive in their attitude towards women. And in their lab, out of 18 research students in the lab, 11 were women. So that's rather interesting. So X-ray crystallography was one of the fields. I mean, the women were there were very low representation of women in physics at that point of time. But X-ray crystallography was a field in which women made the first headway. There were a lot of women crystallographers that came up. And Kathleen Lonsdale was a product of this lab, very important crystallographer who was one of the first, or the first two women to become a fellow of the Royal Society, structure of benzene. And of course, her student, Dorothy Hodgkin, went on to win the Nobel Prize, doing extremely important work on insulin and stuff like that. And of course, there was Rosalind Franklin and many other very important women crystallographers. But strangely, and again, I mean, this is off the internet, though it's a fairly reliable site, I think, of a science museum, but I wouldn't vouch for it completely because I don't know. So, but apparently today, the International Union of Crystallography's online list of eminent crystallographers is more than 90% male. And this was like way back in time, somehow things didn't quite progress in the way it was supposed to, I guess. Okay. So at the end of her study research, this is a chapter from her thesis. This is her front page of her thesis, submitted in November 1955. X-ray and differential thermal analysis of Indian clays. That's what the title was. And this is the first page of her thesis. And for whatever it's worth, this is the original object, just a big black book, bound black book. So I thought I'd show it as well. Okay, so and this was, she was the first woman to receive a PhD in physics from Calcutta University as a result of this submission. Those days, I think they used to call it DPhil. And perhaps also the first woman in the whole of India. I'm not entirely sure of that, because Calcutta University was sort of a pioneer in at that point of time. So, but that's speculation. Okay. Here is slides from pictures from her thesis. And these are the pictures she took from her through her equipment of her X-ray tube probe. And these are very faint captions, but if you can, I'll read it out. It says Santal Pargana bentonite. So all these are indigenous clays, and the structures of them were investigated. Now, the thing is that at that point of time, reconstructing these structures was a very difficult, it was quite a laborious and difficult task, which has changed a lot since the advent of the computers. They didn't have access to computers, so the analysis was not trivial at all. So along with the X-ray probes, so to get the complete structure, you had to probe the clay sample from multiple directions. And one of the techniques she had used was also something called differential thermal analysis. And that's where basically you have your material under study and you have inert reference, a control sample, and they undergo identical thermal cycles. And from the temperature difference between the sample and reference, you can find out certain characteristics of the sample. So this differential thermal analysis, so she combined, so the molecules are complicated. So only X-ray analysis may not reveal the entire structure. So she combined differential thermal analysis and X-ray diffraction, plus also some chemical analysis to arrive at the final structures. Now, here is a picture which has been shared widely on internet. Some of you might have seen, and this is a very iconic picture. This is a picture of my mother, Purnima, with Schopenhauer on one side and Paul Dirac on the other side. And this was taken in the botanical gardens when Dirac visited Esenbos in the 50s. While she was a graduate student, and she was given the responsibility of taking Dirac around and looking after them. And so this is a very unique picture, an amazing picture where Dirac, half of the particles of the world obey Bose-Einstein statistics, the rest obey Fermi-Dirac, and Dirac was, of course, like one of the greatest scientists of all, greatest physicists of all times, and was like one of the creators of quantum mechanics. So this is, and he came to visit Esenbos and gave lectures spent some time in Calcutta University, and that was also a unique experience for her. So this is, so I just wanted to share a picture. And along with, so I think the second most uh, greatest influence, I would say, Nourish Sengupta, her father was a great influence in her life and propelled her to, gave her this freedom and this confidence that as a woman, I can do anything. You know, there are no barriers, you know. And the second person was her mentor, S.N. Bose, who was not only a mentor and a teacher to her, but also a real philosopher and guide. And she shared an incredible bond with him. You know, so it was quite, and respected him from really the bottom of her heart. And it was like, she was like one of the guiding lights in her life, definitely. Okay, so, okay, I should also talk about the trailblazers who came before, just to get a perspective on where she stood. She got as the first woman PhD from Calcutta University, and you have those of you who have heard the lecture on Biba Chaudhuri before this may know that Biba Chaudhuri, she was born 1913, so that was 14 years before Purnima Sinha. And she did phenomenal work in cosmic rays, and her work was really, you know, Nobel Prize quality. And she came from a Brahmo family, and she's so 1949. So that is much before Purnima Sinha. But the thing is that she started her research with D.M. Bose in Calcutta University. But later, due to the unavailability of photography plates, and there were difficulties with progressing with the research, so she moved to Manchester and finally got her PhD from Manchester. But if she had been continued in Calcutta University, she would have definitely been the first. Purnima Sinha and Biba Chaudhuri, as far as I know, did not overlap at all. I haven't, so because I think she left, she was much senior. She left for Manchester before that. The other person is Osima Chatterjee, who was like 10 years old, her senior. And she was actually, she got her DSc in chemistry in 1944. And she was the first woman to receive a doctorate degree in science from an Indian university, or in all of India. And she was a pioneering chemist. She also got many other awards. She was, Purnima Sinha did overlap with Osima Chatterjee in the sense that the labs were close to each other, and she took a lot of help. She knew her well, and her students were contemporary of Purnima Sinha, and she took a lot of help from Osima Chatterjee and Sushil Mukherjee, another very important organic chemist, in the chemical analysis part. Okay. All right. So, okay, let me so this is let me go back to the timeline a bit. Let's see how am I doing on time. So here, let me read out a little excerpt from an article she wrote in Leelavati's Daughters in her own words. This is a publication on women scientists from Indian Academy of Sciences. So this is what she says. Around the middle of 1951, I started working on my PhD with Professor S.N. Bose at the Khoira Laboratory in Kolkata. He advised me to carry out an investigation on the structure of clay from various parts of India. He suggested that I could use techniques of thermal and chemical analysis along with X-ray scattering, and also suggested that I fabricate my own X-ray tube of the Coolidge kind so that the parts could be dismantled and put together at will. At that time, about 10 of us were involved in experimental research at the Koira laboratory. Each of us used to fabricate his or her own instrument according to individual need. This was an unwritten rule in our laboratory. The more experienced research students used to initiate the newer students in this mode of doing research, and Professor Bose would routinely keep track of problems we faced in the lab as well as our progress. There was constructive cooperation between fellow students and people. We all enjoyed the excitement of doing science in this manner. Okay, so the high voltage transformer used for our X-ray equipment was fabricated in the applied physics department of our university. We had put together our X-ray equipment from the World War surplus gathered in the lane behind Dr. Bidan Rai's house near Wellington Square. The rest of the parts were put together at the workshop in our department. Our efforts in the X-ray laboratory finally led to a complete classification of about 50 clay samples, etc., like teolinite, montmorillonite, whatever. So the point is that this was the atmosphere out there, and I could see just a couple of personal anecdotes I want to share at this point. I think I should wind up in a little while. I do have time up to how much time do I have, Shubheshna?
So this is for 1 hour, ma'am. So you have another 5-10 minutes, but we can extend for some time. So
Okay,
let's
okay.
complete
So
this
I
with
think
that.
I think I need a little more time out there. Okay,
That
so not too much. I don't like extending beyond. So two incidents I want to share, two anecdotes. One of them being from S.N. Bose, because one has to appreciate that he had the confidence. He invited. He actually asked my mother to join him as a research scholar, and he assigned this complicated task of fabricating an instrument to a woman. And she repeatedly states that there was not only no discrimination whatsoever between men and women in his lab, in his interaction with them, he was also very actively encouraging women. And as a matter of fact, once she was visiting his home, which they were very close. So it was a very informal atmosphere. In any case, he was that kind of person. And his daughter, Shobhan Bose's daughter, looked at her hands and said, "Why aren't you wearing bangles?" Which was very unconventional for women at that time. You always had to wear a certain amount of jewelry, and my mother wore none. So before she could answer, Shodhan was said, and this I should say in Bengali, and I'll translate. Most of you know Bengali. He said like, ও চুড়ি পরবে কেন? ও কি সারাদিন রান্নাঘরে কাটায়? ও বড় বড় যন্ত্র তৈরি করে. So he said like, why should she wear bangles? She doesn't spend her whole day in the kitchen. She fabricates heavy instruments. So it goes to show like what kind of person she was also. And the second thing is like from my experience from her, seeing her later in life, and she was always very comfortable around instruments. She was always taking things apart, putting them together with confidence. She also loved working shoulder to shoulder with workmen, all the masons, electricians, carpenters, everybody, she knew the detailed instructions. She liked to, she was good with her hands. She loved that. Me being a theoretical physicist, like stayed away from that completely. And the thing is that with my father, he was not at all, he could not even hold a screwdriver correctly, I think. So the gender roles were quite reversed in my house. And as a matter of fact, when my father was visiting the US for some conference, a friend said like, in the end, would you like to buy some gifts for your wife? Should I, which store should I take you to? Would you like to buy some jewelry, clothes, whatever? He said, take me to a hardware store, and he bought her an electric drill, and she was thrilled with that. So, so that's the kind of confidence she had in like handling instruments. She loved handling instruments. Okay, so so going back to the timeline, in 1956, the same year she got her PhD, she got married to Sinha, an anthropologist, my father, and this was also this was also like a thing which was unconventional because they had an intercaste marriage with a lot of resistance from my father's side of the family, none from my mother's side of the family, and. So and they got married on the day Hillary and Tenzing conquered the Everest. So this was actually it is 1953 probably. I don't know. Like this is. I got a big mixed. I think it was announced later or something like that. But this was like an amazing partnership, and I think like there was a lot of. First of all, he was very supportive. Secondly, a lot of the anthropology field work that he did, my mother worked in partnership, applying many scientific methods or uh, uh, from the data that he got. Okay? So this just to like run through this briefly. So 1960 to 61, right after she worked for the Geological Survey of India. Then she followed my father to the US, where he was there for 3 years. And between 63 and 64, she actually moved to biophysics for a while in Stanford University. Came back, worked for a couple of years in Bose Institute, and then for a long stint, she worked in the CSIR lab, Central Glass and Ceramic Research Institute, and passed away in Bangalore in 2015. So, now let me move on to, this was a science, so I'm going on the opposite orientation. And so just flash a slide on this. So in the biophysics group, she worked on a rather unconventional subject on the origin of life, connecting the idea origin that surfaces may have been clay surfaces may have been the substrate for the origin of biogenic polymers. And she continued to work in this area, but this was, I think, a little non-mainstream, and I don't think there were publications out of this. And then again, in CGCRI, she continued to work on clay minerals and applications to ceramic color. And she worked on an interesting project collaborating with traditional potters of Pakura on ceramic clays. So now coming to the other aspects, okay, and this is, so remember the title of the book was had music in it. And again, like here also, she was a trailblazer when while she was in MSc, she was learning Hindustani classical music from tabla from Pandit Gyan Prakash Ghosh, when tabla was exclusively a male domain. Women just didn't play the tabla. Then when my father was a visiting professor in Chicago, she gave a series of, she was also very interested in music and music analysis. She gave a series of 12 lectures on Indian music at the University of Chicago, which culminated later into a book called The Approach to the Study of Indian Music. This cover design is also done by her. Much later in life, and one of the chapters in this book is also the analysis of tribal music from Manbhum area, which she learned from my father. So that's what I said. Like it was a interesting collaboration. And another piece of work which she did, which was published in the Asiatic Society Journal when she was 80 plus, which was a comparison of Jaroa songs of the Andaman tribe, uh, and Vedic chants. And she analyzed the melodic pattern in a very scientific manner using a particular method and saw the similarities. So she was very diverse in her interest. And then coming to art. So this is, yeah. So this is like some of her art, and specifically since talked about, as I said, her life. And this is a huge mural, terracotta mural that this is in the Vice Chancellor's house in Vishwabharati. And she did the firing in the kiln, did the artwork herself. She was essentially self-trained. This is another piece of work. She also had a solo art exhibition at London Gallery in Shantiniketan. This is another piece of work where she collaborated with potters. And this whole thing was under her directions, made on the potter's wheel and put together. Okay. The last thing I'm going to talk about, hopefully, is science writing in Bengali. She was very passionate about it, and this was also something mentored by, inspired by Shatyan Bose, who really was a firm believer in writing science in your teaching science in mother tongue, and writing in Bengali. So she wrote profusely about science and other things also in many magazines they were published. And she wrote a very comprehensive biography of Shatyan Bose called Bigyan Sadhana Dharaya Satyendranath Bosu. And she had interviewed him extensively. There was another book called Amar Kotha. She translated very important work of Schrödinger called Mind and Matter into Bengali. That was another piece of, and she, result of this, Bongyo Bigyan Parishad honored her with an award for science writing in Bengali. To finish, in a very, this was her last piece of work, in the sense that she was 80, much into her 80s, and she had a deep interest in biology, which continued beyond her biophysics research days. And this is her last piece of work at 80 plus. And this was an excellent Bengali translation of this book called Unraveling DNA, which has very detailed information about molecular biology. And this unfortunately could not be published for various reasons of, the Kamenetsky's agent asked for too much money for the rights, etc. So anyway, this is what she did. And post-retirement, she took early retirement from and she and my father spent a large part of their life running an informal school for the local tribal children in the neighborhood, and they called it Milamashai Patshala. And this is a picture from that. And I will close here. And thank you very much for the opportunity.
Thank you, ma'am.
So I should stop sharing here. Should I stop sharing? So
yeah, you can do that. And I would like
okay.
Let's open for question answers. I'm sure we will have people who want to ask questions. So anyone from panelists and from the attendees also, any questions you have, please raise your hand. I can bring you up to the panel. And I would request some of our panelists to come on video and come up with their questions and whatever they want to add after this.
I'm Suprakash. Can I make a comment?
Yes, sir. Absolutely. Thank you
So,
for joining.
Sukanda rightly pointed out the uh, unusual title of the book, and I think I would like to give some explanation to that. Sukanda may remember that when I met her at the Boston Institute during one of the seminars, I proposed that we may write a book on Purnima Sinha. And then the idea was that because she was the first woman PhD physicist from Calcutta University, that was our basic idea. And Sukanda agreed to our proposal, and I requested her to provide some information, more information about her mother, which will help us to write the book. Now, while writing this book, we found that she is equally talented in arts, music, and other things as good as in science. So we are a little bit confused. And to highlight his other qualities, because she was a scientist, everybody knows that. But in order to highlight her other qualities, particularly the arts and the other things, so we thought that probably we will write in a different, slightly in a different way to be more attractive to the general viewers also. I mean, those who will write or want to buy the book, they will be surprised to see, hey, what is that? Clay, craft, music, and science. So to be more attractive and to highlight our other qualities, we put that thing. So that was the basic idea. So
actually, it was a very nice title. It just sort of sums up.
Thank you. And Sukanya, as you know, in science, when we write papers, when you are confused who will be the first author, usually the person who contributed most in that paper is the first author. And when there is a confusion about 3 or 4 people, who will be the first author, and we can judge who is the equal contributor, then we go for the alphabetical order. That is the usual practice that we follow. So we thought maybe in that case also we'll follow the same practice, play, craft, music, and science. And so it is not that to undermine her scientific qualities. It's not that. So just this is my clarification.
Not at all. As a fact, the fact that Clay came first as an alphabetical order was a very nice thing, because really that sort of tied together art and science aspects. And yeah, it's very apt title, I think.
Okay. And now I
may
have
I ask
to
something?
leave the session because I have another event at 8 o'clock. So I have to.
Sure.
I'm sorry for that.
Saying something, yeah.
Yeah. Shukannadi, I happen to know that both you sisters are into physics.
Yes.
So, what made both of you choose? Means, how did you get connected to your mother's specialization?
Well, I think there was, of course, inspiration, like that from my mother. I think and I just felt attracted to science, though I have like an almost equal attraction to many aspects of arts. But but I think like in my case, and actually even in my sister's case, not only my mother but one of our high school teachers in science, in physics, played a very great role. And I think he was the prime motivator, Anjan Das Gupta, who really tilted the balance towards physics. And though like both of us turned out to be theoretical physicists, we just didn't have the experimental prowess or inclination that my mother had. So we did physics, but our temperaments were a little different.
Okay. Thank you.
If I may add, since Shukana is a good friend of mine, Shukana is a very, should I say, a very good singer, very well-trained classical singer. So she's not only taken physics from her mother, but also her interest in music, in addition to, her flair for excellent writing, etc. Because she was awarded the Rabindra Puruskar for her book, College. She writes equally well in Bengali.
Yes, my interest in music was certainly fueled by my mother too. Yes.
And I'll just add that I was fortunate to meet her mother once, and I remember that very fondly, and I was amazed at a woman um, who was equally, what should I say, very motherly. At the same time, she was so talented in so many ways. My interest was not only in her science, but the fact that she was a tabla player and she was a student of my mother's uncle,
Yes.
Jan Prakash Bose. So I want, and she used to she shared stories of how the classes went on and how much she enjoyed both, as a PhD student of Sir Shwatan Bose as well as her tabla lessons. So it was fascinating, actually. So it was a very rare, very dear to my heart. Very grateful that she kind of agreed to give this talk, share all this with us. Although 1 hour is too little for a woman such as Purnima Sinha, a rare gem indeed. I think another friend of mine, Paul Chattopadhyay, in the chat box, he has written something. Sudeshna, you may read it out.
Yeah, I think I can bring him up so that he can also address. Let me find out his. Yes, I will make him panelist so that he can come on video. Sir, you can unmute yourself.
No, I just made a sort of comment that it's very unusual to see a person with such depth in both in science as well as in the arts, and you know, I had known her for quite a bit of time, and she never compromised. I think, you know, when her sense of being true to things, you know, not just I mean, true to everything around her in her life, and the truth in science. She was quite uncompromising in this, you know. I mean, so, and at the same time, never stopped searching for beauty in everything around her. So this is a remarkable quality, and yeah. So that's what I thought. Just I would say that.
So Shukana, may I ask one question? You know,
Sure.
when there's a woman of someone like Purnima Sinha, and you've seen her from the closest quarters possible, we always talk about work-life balance and women having to, you know, having a very tough time balancing between family and career. So if you could share, you know, how someone like her managed this so well.
I think, you know, like she managed it very well, and because, and also that is largely attributable also to having a very supportive partner, which is always not there. So with my father, you know, he was constantly supportive. So there was no even. And as I said, like even her background was such that around that time, every woman is pressurized into getting married. There was absolutely no pressure from her end of the family. So she came with a very unconventional, you know, background, and she managed home life and work very efficiently. You know, there was no. It was just also a very no frills kind of household, in the sense that we would rather spend a lot more time reading and discussing than, you know, preparing elaborate meals, and all of us were inculcated into that culture, you know. So that, I think, was the driving force. And also like the entire family, I think children were given a lot of freedom and also taken very seriously, like their opinions. So he gave a lot of freedom and was like a friend.
Thank you.
We have Ratnamala Mishra from the audience. She wanted to ask something. Ma'am, you can unmute yourself.
She's a relative too.
Yeah, so she's on mute.
Hello, can you hear me?
Can hear you.
Momo,
Can hear you.
Momo. Okay.
Can hear you.
So it was a pleasure. Yes, it was a pleasure listening to Sukarna speaking about her mother, and I know them for a long time. Their relations, and from childhood, I had
Yes.
excellent memories of their household in general. I mean, Purnima Sinha and Shurajit Sinha and the two daughters. And well, while she was showing all the murals and the uh, paintings done in the Vishwabharati house, I remember that when we had been there, she was working on this elongated, stylized woman, tribal woman on the floor. On the floor.
Yeah.
So, and it
Yes,
came
yes,
out
yes.
so nicely. Yes. And
It was
she was an exceptional woman. And I had gone with my parents. And about the household, I remember the impression I have is their house was stacked with books from the floor to the ceiling of every wall of every room. You know, I mean,
exactly.
it was
Yeah.
full of books, full of
Yeah.
books. Then my mother, we were staying with them. Then my mother one day shampooed her hair and then asked Runudi that can I get some shindur to put on my head? And the most unconventional thing Runudi said was, yes, look for a homeopathic medicine bottle, and you might find shindur in that. So it was the most
yeah.
unusual place to keep shindur in, and that's how my mother found. And very very personal and funny stories about how Shurajit was the vice chancellor of the university, so he had to maintain a certain sort of dress code or something, and he had 7 or 8 pairs of the uh, same white clothes, so that it got washed every week, and then he would wear a starched and iron thing every day, and the whole cooking was sublet to a contractor type of person, mess contractor, and whatever he put on the table, they were very happily consuming till my father said that, he's cheating you. He's cheating you a lot. He's charging maybe double the sum, and you're not also aware that how much you're paying for such a meal. So those were memories I remember, and we had such a lovely time singing and gossiping and sitting on the veranda. And that's all I remember about Runudi, who was Purnima's. And first of all, I am an ardent fan of her, and secondly, I am a relative. I am a fan first, and then a relative. So that's what I wanted to tell Shukarna, and she is very much like her mother, very articulate and very precise, and she talks so nicely, and she
Thank you.
writes so well. She writes so well. Yes. Okay.
Thanks.
Thank you, ma'am. Thanks, everyone. Okay, I will just quickly, now we are almost end of time.
Yes.
Let me just conclude the session. If anybody else has anything to say, else we will now slowly close. And I will just So we have just a small token of thanks from all of us in IEEE Kolkata section and Women in Engineering Kolkata section, Shrikanda ma'am, and we have contributed 20 trees in the Sundarban National Park project in your name.
Wonderful. That's so lovely. Thank you.
Thank you very much. Thanks everyone for joining, and we will close today's session now.
Thank you. Thank you.
Thank you.
Okay, so